discussing. So using the voltage, you can identify the reactivity. Another example, if I say you have electrode X, this one is Y, and this one is Z. And you connect a voltmeter. And the element, the metals, this one is X, Y, and this one is X and Z. The movement of electron is from X to Y, and the movement of electron is from Z to X. This was producing, say, 3 volts. And this is producing 1.5 volts. The question is, set up the reactivity. First, you have to set up the reactivity or identify which is more reactive. Between X and Y, which is more reactive?
Y.
The movement of electrons from X to Y. So if movement is from X to Y, because the movement of electron is always from more reactive to less reactive. So this shows that X is more reactive. Between X and Z, the movement is of electron from Z to X. So which is more reactive?
Z.
Z. And you have to set up the reactivity. So how you set up the reactivity? So what you will do, as you identify X is more reactive than Y, so X should be above and then Y should be below. And how much is the gap between them? If it's 3 volts, so you can draw a 3 centimeter line to explain this gap. So 3 centimeter or 3 volts. Then between X and Z, Z is more reactive. So Z should be above, but how much is the difference? 1.5. So 1.5 difference means they will have small difference in the reactivity. So this is 1.5 example. Now the question is, you're using 2 electrodes, Y and Z. And you want to identify the voltage produced. What is the voltmeter reading here? Between Y and Z, what will be the voltage? From Y to Z.
4.5.
4.5, because from Y to X is 3 and from X to Z is 1.5. So total will be 4.5. So this will give 4.5 volt. And what will be the direction of movement of electrons?
Z to Y.
Z to Y, because Z is more reactive and Y is less reactive. So using a voltage and a chemical cell, you can identify the elements or the metal which is more reactive and the metal which is less reactive. Is it clear? The concept of reactivity series? In what case you will subtract? It depends. Like example, another example. If you have electrodes, this one is say Y and this one is Z. A voltmeter, The movement of electron is from x to y, and movement of electron is from z to x. X, y, x, z. And the voltages are given. Example, the voltage here is given 3 volts. Voltage here is given 1 volts. Between x and y, which is more reactive? X and y, x is more reactive. Between y and x and z, which is more reactive?
Z.
So z is more reactive. Now you set up the reactivity between x and y because it's a 3 volt difference. So and we know y is more reactive. So they should have a greater difference in the reactivity, and this one is 3 volts. Between x and y, x and z, z is more reactive, but only 1 volt means a small difference in the reactivity. This is 1 volt. If a question is what will be the voltage produced if we use z and y,
2.
so it will produce 2 volts. So this one is y and z, and how much voltage it will produce, because we need this voltage from y to z. So this is unknown. If from x to y is 3, from x to z is 1, so the difference 3 minus 1, that's equal to 2. So this will be 2 volts. And the movement, which is more reactive, y is more reactive, so the movement is from y to z. Is it clear, this example? The diagram shows a simple cell or a voltaic cell or a galvanic cell. It consists of a voltmeter, zinc electrode, copper electrode, and electrolyte. So what happened? The zinc atom will go inside the solution as a zinc ion. An electron will travel from zinc surface to copper surface. Which statement about the process occurring when the cell is in operation is correct?
Sir, why from zinc?
What?
Why traveling from zinc to copper?
Because zinc is more reactive, so zinc tend to lose electron first. I explained in the beginning, for a chemical cell, the more reactive metal tend to lose electron first, so that's why the electron travel always from more reactive metal surface to less reactive metal surface. That's why it is zinc. So copper ions are formed in the solution, copper ions are not formed. Electron travel through solution. Electron never does not travel through solution. Electron can only move through wire. The zinc electrode mass increases. No, its mass will decrease. Why? Because the zinc atom is changing into zinc ion, so size will not increase. The size of this electrode will decrease because the amount of zinc is changing, so the size will decrease. So what we are left with, zinc atom is changing into zinc ion by loss of 2 electrons. The diagram shows a simple cell. Which pair of the metal produce the largest voltage? I told you the voltage is produced is directly proportional to the difference in the reactivity. So for this, first you have to recall the reactivity series, which is potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, and gold and platinum. So if I use iron and copper, so iron and copper, if I check their reactivity, small difference, only one element difference. Magnesium and copper, magnesium and copper, magnesium and zinc, magnesium and zinc, zinc and copper. The diagram shows a simple cell. The diagram shows a simple cell. Which pair of a metal would electron flow from X to Y? So X should be more reactive and Y should be less reactive. So metal X should be more reactive than metal Y. What could be the answer? So when you check the reactivity, zinc is more reactive than iron. So in metal X should be zinc and metal Y should be iron. The reactivity series for a number of different metals is shown. The diagram shows different metal strips dipped into electrolyte. Which pair of metal produce the highest voltage? Which produce the highest voltage? Copper and magnesium, magnesium and platinum, magnesium and zinc, or silver and platinum? Yeah, B is the right answer, magnesium and platinum, because the greater difference in the reactivity. The diagram shows a simple cell. Two metals produce the highest reading. Which metal produce the highest reading? Yeah, which case it will produce the highest reading? So you have to again set up a reactivity series. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold, and platinum. Magnesium and copper. So if I take magnesium and copper, this is magnesium copper. Magnesium and iron, magnesium and iron. Zinc and copper, and zinc and iron. So it's magnesium and copper. A is the right answer. Which metal combination produce the highest reading? Yeah, that's correct. D is the right answer, because magnesium and copper have the greater difference in the reactivity, so it produces the highest voltage. So these are some questions related to chemical cell. Any doubt related to today's class? So we are done with topic electricity and chemistry. We started with the labels, the working of electrolytic cell, then discussed the electrolysis of molten and aqueous electrolytes, then the active electrode, and the last topic is the chemical cell. There is a topic in the book, you will find electrolysis of or extraction of aluminium, that we will do in the metal chapter, chapter 10. Any doubt related to the class today?
No, sir.
Okay, I'll end the session and share the recording.